Nitric oxide, nitrogen oxide or nitrogen monoxide is a colorless gas with the formula NO. It is one of the principal oxides of nitrogen. Nitric oxide is a free radical, i.e., it has an unpaired electron, which is sometimes denoted by a dot in its chemical formula, i.e., NO. Nitric oxide is also a heteronuclear diatomic molecule, a historic class that drew researches which spawned early modern theories of chemical bonding, an important intermediate in chemical industry. Nitric oxide forms in combustion systems and can be generated by lightning and thunderstorms. In mammals, including humans, nitric oxide is a signaling molecule in many physiological and pathological processes. It was proclaimed the molecule of the year in 1992. The 1998 Nobel Prize in Physiology or Medicine was awarded for discovering nitric oxide's role as a cardiovascular signaling molecule. Nitric oxide should not be confused with nitrous oxide N2O, an anesthetic, or with nitrogen dioxide NO2, a brown toxic gas and a major air pollutant. Reactions with D and triatomic molecules. Upon condensing to a liquid, nitric oxide dimerizes, but the association is weak and reversible. The N distance in crystalline NO is 218 pm, nearly twice the NO distance. Since the heat of formation of NO is endothermic, NO can be decomposed to the elements. Catalytic converters in cars exploit this reaction. 2NO2 plus N2. When exposed to oxygen, nitric oxide converts into nitrogen dioxide. 2NO plus O2 to NO2. This conversion has been speculated as occurring via the ONO intermediate. In water, nitric oxide reacts with oxygen and water to form HNO2 or nitrous acid. The reaction is thought to proceed via the following stoichiometry. 4NO plus O2 plus 2H2O 4HNO2. Nitric oxide reacts with fluorine, chlorine, and bromine to form the nitrosyl halides, such as nitrosyl chloride. 2NO plus Cl2 2-nol with NO2, also a radical. NO combines to form the intensely blue dinitrogen trioxide. NO plus NO2 on NO2. Organic chemistry. Nitric oxide reacts with acetone and an alkoxide to a diazonium dilate or nitrosohydroxylamine and methyl acetate. This reaction, which was discovered around 1898, remains of interest in nitric oxide prodrug research. Nitric oxide can also react directly with sodium methoxide, forming sodium formate and nitrous oxide. Coordination complexes. Nitric oxide reacts with transition metals to give complexes called metal nitrosyls. The most common bonding mode of nitric oxide is the terminal linear type M-NO. Alternatively, nitric oxide can serve as a one-electron pseudohalide. In such complexes, the M-N-O group is characterized by an angle between 120 degrees and 140 degrees. The NO group can also bridge between metal centers through the nitrogen atom in a variety of geometries. Production and preparation. In commercial settings, nitric oxide is produced by the oxidation of ammonia at 750 to 900 degrees Celsius, normally at 850 degrees Celsius, with platinum as catalyst. 4NH3 plus 5O2 NO plus 6H2 auth uncatalyzed endothermic reaction of oxygen O2 and nitrogen N2, which is effected at high temperature greater than 2000 degrees Celsius by lightning, has not been developed into a practical commercial synthesis. See Birkeland-Ade process. N2 plus O2 NO. Laboratory methods. In the laboratory, nitric oxide is conveniently generated by reduction of dilute nitric acid with copper. 8HNO3 plus 3Cu3 copper 2 nitrate plus 4H2O plus 2 NO. An alternative route involves the reduction of nitrous acid in the form of sodium nitrite or potassium nitrite. 2 sodium nitrite plus 2 Ni plus 2 H2SO 4 I2 plus 4 sodium hydrogen sulfate plus 2 number 2 sodium nitrite plus 2 iron 2 sulfate plus 3 H2SO 4 iron 3 sulfate plus 2 sodium hydrogen sulfate plus 2 H2O plus 2 number 3 KNO2 plus KNO3 plus Cr2O3 2 potassium chromate plus 4 notha iron 2 sulfate root is simple and has been used in undergraduate laboratory experiments. So-called monoate compounds are also used for nitric oxide generation. Detection and assay. Nitric oxide concentration can be determined using a chemiluminescent reaction involving ozone. A sample containing nitric oxide is mixed with a large quantity of ozone. The nitric oxide reacts with the ozone to produce oxygen and nitrogen dioxide, accompanied with emission of light chemiluminescence. NO plus O3 NO2 plus O2 plus H nu, which can be measured with a photodetector. The amount of light produced is proportional to the amount of nitric oxide in the sample. Other methods of testing include electroanalysis, amperometric approach, where NO reacts with an electrode to induce a current or voltage change. The detection of NO radicals in biological tissues is particularly difficult due to the short lifetime and concentration of these radicals in tissues. One of the few practical methods is spin trapping of nitric oxide with iron dithiocarbamate complexes and subsequent detection of the mono-nitrosyl iron complex with electron paramagnetic resonance (EPR), a group of fluorescent dye indicators that are also available in acetylated form for intracellular measurements exist. The most common compound is 4,5-diaminofluorescein (DOF2). Environmental effects. Acid deposition. Nitric oxide reacts with the hydroperoxy radical HO2 to form nitrogen dioxide NO2, which then can react with a hydroxyl radical O to produce nitric acid HNO3. NO plus HO2 NO2 plus O. NO2 plus OHNO3 nitric acid, along with sulfuric acid, contribute acid rain deposition. Ozone depletion. Furthermore, NO participates in ozone layer depletion. In this process, nitric oxide reacts with stratospheric ozone to form O2 and nitrogen dioxide. NO plus O3 NO2 plus D oxygen monoarsenide seen in the concentration measurement section. This reaction is also utilized to measure concentrations of NO in control volumes. Precursor to NO2. As seen in the acid deposition section, nitric oxide can transform into nitrogen dioxide. This can happen with the hydroperoxy radical, HO2, or diatomic oxygen, O2. Symptoms of short-term nitrogen dioxide exposure include nausea, dyspnea and headache. Long-term effects could include impaired immune and respiratory function. Biological functions. NO is a gaseous signaling molecule. It is a key vertebrate biological messenger, playing a role in a variety of biological processes. It is a known bioproduct in almost all types of organisms, ranging from bacteria to plants, fungi, and animal cells. Nitric oxide, known as an endothelium-derived relaxing factor (EDRF), is biosynthesized endogenously from L-arginine, oxygen, and NADPH by various nitric oxide synthase (NOS) enzymes. Reduction of inorganic nitrate may also serve to make nitric oxide. The endothelium inner lining of blood vessels uses nitric oxide to signal the surrounding smooth muscle to relax, thus resulting in vasodilation and increasing blood flow. Nitric oxide is highly reactive, having a lifetime of a few seconds, yet diffuses freely across membranes. These attributes make nitric oxide ideal for a transient paracrine between adjacent cells and autocrine within a single cell signaling molecule. Occupational safety and health. In the U.S., the Occupational Safety and Health Administration (OSHA) has set the legal limit, permissible exposure limit for nitric oxide exposure in the workplace as 25 ppm (30 mg per cubic meter) over an 8-hour workday. The National Institute for Occupational Safety and Health (NIOSH) has set a recommended exposure limit (REL) of 25 ppm (30 mg per cubic meter) over an 8-hour workday. At levels of 100 ppm, nitric oxide is immediately dangerous to life and health. References. Further reading. Butler A. and Nicholson R. Life, Death and No. Cambridge 2003. ISBN 978-0-85404-686-7. Van Fossen, E. E., Vannon, A. F. eds. Radicals for Life, The Various Forms of Nitric Oxide. Elsevier, Amsterdam 2007. ISBN 978-0-444-52236-8. Ignaro, L. J. ed. Nitric Oxide, Biology and Pathobiology. Academic Press, San Diego 2000. ISBN 0-12-370420-0. External links. International Chemical Safety Card 1311. CDC – NIOSH Pocket Guide to Chemical Hazards. 1998 Nobel Prize in Physiology, Medicine for discovery of NO's role in cardiovascular regulation. Nitric oxide and its role in health and diabetes. PDF. Microscale gas chemistry, experiments with nitrogen oxides. Your brain boots up like a computer, new insights about the biological role of nitric oxide. Assessing the potential of nitric oxide in the diabetic foot. New discoveries about nitric oxide can provide drugs for schizophrenia. Nitric oxide at the chemical database